Crash course on data science, big data analytics. Big data. Explore the challenges and opportunities of working with large-scale datasets, and learn about distributed computing frameworks such as Hadoop and Spark. Data science is a field that is constantly evolving and adapting to new technological advancements. One of the biggest challenges in data science is working with large-scale datasets, also known as big data. Big data is characterized by its volume, variety, velocity, and veracity. The volume refers to the sheer size of the data, which can range from terabytes to petabytes. Variety refers to the different types of data, such as structured, semi-structured, and unstructured data. Velocity refers to the speed at which data is generated and needs to be processed. Finally, veracity refers to the uncertainty and noise present in the data. Working with big data requires specialized tools and techniques to manage and process the data efficiently. One of the most popular frameworks for managing and processing big data is Hadoop. Hadoop is an open-source framework that allows for the distributed processing of large datasets across clusters of computers. One interesting example of Hadoop in action is how it was used by the New York Times to process and analyze over 4 million digitized articles dating back to 1851. The articles were stored in an Hadoop cluster, which allowed for efficient processing and analysis of the data. The results of the analysis were then used to create a searchable database of historical news articles, which is now accessible to the public. Another popular framework for managing and processing big data is Apache Spark. Spark is an open-source data processing engine that allows for the fast and efficient processing of large datasets. Spark is particularly well-suited for iterative machine learning algorithms and graph processing. An interesting example of Spark in action is how it was used by Uber to detect and prevent fraud. Uber generates a large amount of data from its ride-sharing service, which can be used to detect fraudulent activity. By using Spark, Uber was able to process and analyze this data in real time, allowing for the quick detection and prevention of fraudulent activity. In addition to Hadoop and Spark, there are many other popular tools for big data analytics. Here are the top 12. 1. Apache Hadoop, an open-source framework for distributed storage and processing of large datasets. 2. Apache Spark, an open-source data processing engine that allows for fast and efficient processing of large datasets. 3. Apache Storm, an open-source distributed real-time computation system. 4. Apache Flink, an open-source distributed data processing system for batch and stream processing. 5. Apache Cassandra, an open-source distributed NoSQL database management system. 6. Apache Hive, a data warehousing and SQL-like query language for Hadoop. 7. Apache Pig, a platform for analyzing large datasets using a high-level language. 8. Elasticsearch, an open-source search and analytics engine. 9. HBase, an open-source NoSQL database management system that runs on top of Hadoop. 10. MongoDB, an open-source NoSQL document-oriented database. 11. Neo4j, an open-source graph database management system. 12. Teradata, a data warehousing and analytics platform for large-scale datasets. Here are 12 popular big data analytics applications along with brief descriptions of each. Predictive Analytics. Predictive analytics is a type of data analysis that uses statistical algorithms and machine learning models to predict future outcomes based on historical data. It can be used for a variety of purposes, such as fraud detection, risk management, and marketing. Customer Analytics. Customer analytics involves analyzing customer data to gain insights into customer behavior, preferences, and needs. This information can be used to improve customer satisfaction, retention, and loyalty. Supply Chain Analytics. Supply chain analytics involves analyzing data from the entire supply chain, including suppliers, manufacturers, distributors, and retailers. It can be used to optimize supply chain operations, reduce costs, and improve efficiency. Financial Analytics. Financial analytics involves analyzing financial data, such as revenue, expenses, and investments, to gain insights into financial performance and make data-driven decisions. Healthcare Analytics. Healthcare analytics involves analyzing healthcare data, such as patient records, medical images, and clinical trial data, to improve patient outcomes, reduce costs, and optimize healthcare operations. Social Media Analytics. Social media analytics involves analyzing social media data, such as user-generated content and engagement metrics, to gain insights into consumer behavior, sentiment, and preferences. Fraud Analytics. Fraud analytics involves analyzing data to detect and prevent fraudulent activity, such as credit card fraud, insurance fraud, and identity theft. Human Resources Analytics. Human resources analytics involves analyzing employee data, such as performance metrics, turnover rates, and training records, to improve workforce management and optimize HR operations. Marketing analytics. Marketing analytics involves analyzing marketing data, such as website traffic, email open rates, and social media engagement, to measure marketing effectiveness, optimize campaigns, and improve ROI. Operational analytics. Operational analytics involves analyzing operational data, such as production metrics, inventory levels, and supply chain performance, to improve operational efficiency and reduce costs. Text analytics. Text analytics involves analyzing unstructured text data, such as customer feedback, social media posts, and survey responses, to gain insights into customer sentiment, preferences, and behavior. Risk analytics. Risk analytics involves analyzing data to identify and mitigate risks, such as credit risk, market risk, and operational risk. Each of these applications has its own unique challenges and opportunities, and there are many tools and technologies available to support each application. By leveraging the power of big data analytics, organizations can gain valuable insights that can drive business success and innovation. In summary, working with big data presents many challenges and opportunities. Specialized tools and techniques, such as Hadoop and Spark, are necessary to manage and process large-scale datasets efficiently. There are also many other popular tools for big data analytics, such as Apache Cassandra and MongoDB. Now, as for the poem, here goes. Big data, oh big data. So vast and so complex. A sea of information that we must navigate and process. From Hadoop to Spark. And everything in between. We must find the tools to make sense of the unseen. Challenges abound as we try to wrangle the volume, variety. *****. Start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html?8 equals 7989335 as a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for kind support our AnHub Metaverse channel, and please watch more interesting videos here.